Hello everyone! Welcome to another video of Toon Techies. Today we'll explore Hamming code generation, a key method for error detection and correction in digital communication. Stay tuned as we break down the process and demonstrate a practical Hamming code generator. Let's get started. Now let's take a look at the components required for our project. We'll be using 2IC7486, 4 green LEDs and 3 red LEDs for indicating outputs, 1 resistor of each 1 kilo ohms and 470 ohm, a PCB to assemble the circuit, 4 SPDT switches for input selection, and a 9-volt battery to power the circuit. With all the components ready, let's move on to the logic diagram. This is the logic diagram of our Hamming code generator circuit. It consists of 6 XOR gates, which generate parity bits based on the input from 4 SPDT switches. Here, S1 represents D3, S2 represents D5, S3 represents D6, and S4 represents D7. The outputs P1, P2, and P4 represent parity bits, while the remaining outputs indicate the input data. Now let's simulate the circuit to see how it works. This is the simulation of our Hamming code generator circuit. As we toggle the switches, the input data bits change, and the XOR gates generate the corresponding parity bits. The LEDs indicate the final Hamming code, where the red LEDs represent the parity bits P1, P2, and P4, while the remaining LEDs represent the data bits. This confirms that our circuit is working correctly in simulation. Now that we've seen the simulation, it's time for the practical demonstration. Let's check how the circuit works after soldering it onto the PCB. That was all about our Hamming code generator project. We saw how XOR gates generate parity bits and how the circuit helps in error detection. Hope you found this video helpful. Don't forget to like, share, and subscribe to Toon Techies for more such electronics projects. Until then, stay powered up, keep experimenting, and keep learning. Goodbye.